just made sure I was saying that, yeah, it's going to be approximate. All right, for question number 3, it says solve the right triangles. So a student asked me to just kind of talk about solving right triangles. I'm not really sure what they wanted from that because there's many different ways how to solve a right triangle based on what type of information you have. So if you have a right triangle and you have 2 sides, then you can use the Pythagorean theorem to figure out what that third side is, right? Which typically we'd call that like C a lot of times. So in this case, we can just do what we call the Pythagorean theorem, and so if we call that A and that B, then remember the Pythagorean theorem is A squared plus B squared equals C squared. I keep on forgetting like my camera's over here. So in this case, I would just do 3 squared plus 5 squared equals C squared. And 3 squared is going to be 9 plus 25 equals C squared. That's 34 equals C squared. And then you just take the square root of both sides. So therefore, C equals the square root of 34. And again, just remember, even though a lot of times when we introduce the square root, we're using that plus or minus. In this case, we don't need to refer to the plus or minus because when we're dealing with the hypotenuse, it's always going to be positive, right? The length of a triangle is always going to be positive. So therefore, we can just say C is going to be the square root of 34. Now, if we're only given one side, that is not enough information for us to use the Pythagorean theorem. So therefore, we're going to want to look to our trigonometric functions. Now, in this case, I didn't say what our missing value was, so let's just say, let's just put C in there again. So in this case, let's say we want to find the hypotenuse, but rather than giving 2 sides, we're given a side and an angle. So in this case, we're going to want to use our trigonometric function. So basically, we want to look for the sine, the cosine, and the tangent. And remember, those trigonometric functions are just a comparison of 2 sides of a triangle based on a given angle. So in this case, our angle here is 41 degrees. And based on that 41 degrees, we can see we have the opposite side as well as the hypotenuse. So therefore, we're going to use the sine of 41 degrees equals opposite over the hypotenuse. Now, to solve for this, we're going to have to solve for C. So to do that, we're going to multiply by a C on both sides. And then we're going to divide by a sine of 41 degrees. Let's break it out and why not. C equals the sine of 41 degrees equals 5. That's not supposed to be multiplied. Okay, and then you divide by the sine of 41 degrees. Okay, so therefore C equals 5 over the sine of 41 degrees. Now, it's very important when you're evaluating your trigonometric functions to make sure your calculator is in degree mode. So what I decided to do in my class is I made sure that all these problems that we're doing with our calculator is kind of in the same chapter, so therefore I'm not confusing students too much as far as converting between radians and degrees. However, they need to be aware of it because when they get to tests or quizzes or tests and exams, they got to make sure they understand which mode that the problem is going to be in. In this case, we're dealing with degrees, so therefore I'll do 5 divided by the sine of 41. I am in degree mode, so I'm good. Actually, let me just double check one more time. Yeah, I'm good. Okay. So I'll do 5 divided by the sine of 41. And I'm getting 7.62, so again, I'm just going to round that